Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on the statistical analysis by using Q-test. In a study measuring air pollution level in particular region, the ozone concentration level in parts per billion were recorded as follows. Determine whether 52.5 is an outlier by applying the Q-test at 95% confidence level. Alright, since the question asks you to calculate the Q-test, so the first thing that you need to do is you need to rearrange the data point from the smallest to the biggest. So apparently this data set have put the data point in sequence, so we just need to find which one is your suspected outliers. So in the question, 52.5 is the suspected outliers. So what we are going to do is we're just going to write up all these values. So this is your outliers, and this one shall be the n+1, which is the nearest data point to the outliers. So the next thing that you need to calculate is what is the W. What is the value of your W? So which is the range? So the range is the largest value minus the smallest. So the largest value is apparently your outliers, which is 52.5, minus the smallest value, which is 45.2. So you will get your range is equivalent to 7.3. Okay, now we are going to calculate the Q-test. So the Q-test is equivalent to your outliers minus the next number nearest to your outliers. So this one should be modulus divided by your range. So you know that your outliers is 52.5 because the question says so, and then since it's here, the nearest is 47.1 divided by your range that you have calculated just now, which is 7.3. So you will get your Q-test is equivalent to 7.3973 times 10 to the power of -1. Alright, so now we are going to refer to your Q table. So the first thing that you need to do, you need to know what is your N. So 1, 2, 3, 4, 5. So we have 5 data points. So 5 N is here. And then it states that it wants to be 95% confidence level. So 95% at 5 is 0.7100. So we can say that your Q critical is equivalent to 0.7100 and your Q test is equivalent to 0.73973. So basically here, by looking at this value, you can say that your Q test is bigger as compared to your Q critical. So since your Q test is bigger than your Q critical, therefore we need to omit the data point. So in the question, you were asked to determine whether 52.5 is an outlier. So since we are omitting the data point, it is an outlier. So indeed that this value is an outlier. So this is the final answer for this question. With the aid of suitable calculation, explain the implication of removal of the outlier to overall analysis of pollution levels. Alright, so given here is the data point from the previous question. So the first thing that you need to calculate is you need to calculate the mean. So the mean of original data point shall be 45.2 plus 46.0 plus 46.3 plus 47.1, and the last value is 52.5. So this one divided by 1, 2, 3, 4, 5 divided by 5, you will get the mean is equivalent to 2.3710 times 10 to the power of 2 divided by 5. So you will get 4.7420 times 10 to the power of 1. So next up, we are going to do the same thing, but we are going to omit the outliers. So we are going to calculate the mean. So equivalent to 45.2 plus 46.0 plus 46.3 plus 47.1. So but this time around is going to be just 4. So you will get 1.8460 times 10 to the power of 2 divided by 4. Therefore, your mean is equivalent to 4.6150 times 10 to the power of 1. Right, so this one is after removing the outliers, and this one is before removing your outliers. So the next thing that we need to do is we need to find what is the standard deviation. So the standard deviation for the one before removing your outliers, so it's the same concept. 45.2 minus your mean, 4.7420 times 10 to the power of 1 square plus 46.0 minus 4.7420 times 10 to the power of 1 square plus the rest of the number, and then you will get the summation of this is equivalent to 34.108. So from here you can get the standard deviation is equivalent to the square root of the value that you have calculated just now, 34.108 divided by n. So your n is 5 minus 1. So you will get a square root of 8.5270, which is equivalent to 2.9201. Right, so you're going to do the same thing, but this time around, instead of 5 values, you just need to calculate for 4 values with the new value of the mean. So you will get a new standard deviation. So for the number that you have removed the outliers, so basically your mean is equivalent to 4.6150. So what you are going to do is 45.2 minus 4.6150 times 10 to the power of 1 square plus 46.0 minus 4.6150 times 10 to the power of 1 square plus so on and so forth. But make sure that you only make the summation until the 4th number only, because you have removed the 5th number. So you will get the summation is equivalent to 8.3020. Hence you can calculate the standard deviation. So the standard deviation is equivalent to the summation values just now, 8.3020 divided by your n. So your n is 4 minus 1. So you will get a square root of 2.7673. Therefore, your standard deviation should be 1.6635. So this is the standard deviation after the removal of your outliers. So if we refer back to our calculation, the standard deviation of original data point is equivalent to 2.9201, and the standard deviation after removal of your outliers is equivalent to 1.6635. So we can say that after removing the outliers, it will increase in precision of the data, because the decrease in the standard deviation. So decrease of standard deviation from 2.9201 into 1.6635. So it shows higher precision due to lower standard deviation. So this is the final answer for this question. Thank you so much for watching this video from the beginning till the end, and I'll see you again in the next video. Goodbye.